Everybody, welcome back to yet another fun and exciting Algebra 2 class. Today we are going to be in chapter number 5 and lesson number 6. That's on page 254. 254. And really today's just an extension of the last class where we were graphing two variable inequalities. Now what we're going to do is we're going to be solving systems of two variable inequalities. And we're going to do that by graphing. We're going to solve them through a means of graphing. And I like this lesson, to be honest with you. It's kind of a neat lesson, and I think by the end, hopefully, you'll like it too. All right, so let's go ahead and jump right into it. You can look there on page number 254 if you want. I'm going to do that first example. And all I'm going to do is I'm going to solve these, and then I'm going to graph them. Remember, systems of equations are two lines on the same graph. Okay, so I'm going to take these two, and I'm going to put them onto the same graph. So I'll do one in, actually I think I'll do one in white and one in yellow, and that way, or actually I'll do one in green and one in yellow. I think that'll help you to see it a little bit better. And what that'll do is when I get it onto the graph, you'll be able to see the two separate graphs because we got to color them in. Remember, we got to solve, and then we've got to test a point, and then we got to color it in. So when we do all that using the two different colors, you'll be able to see it. You may want to use two different colors on your paper as well. You might be able to do it with your shading with your pencil, but there are some things that maybe if you use some color pencils right here, you might be able to see it a little bit better. All right, let's go ahead and solve these. So again, let's put it into y-intercept form just like we did the other day on the last lesson. So I'm going to get, that's going to be negative 3y, sorry about that, negative 3y is less than or equal to negative 2x plus 6. Divide both by negative 3. When we do that, we are going to flip our sign. Don't forget, because we're dividing by a negative. And so negative, negative here, that makes that positive 2/3 x. And then negative, positive, that's going to be a negative 2 right there. All right, so we're ready to graph that one. Now let's come over here and let's go ahead and solve this yellow one. So again, just moving this over to the other side. Divide everything by 3. We don't have to flip the sign this time because it's not a negative. Y less than or equal to negative 2/3 x plus 2. Notice that these are very similar. Okay, really the only difference here was this negative sign right there on that. But they came out different. We have different slope. We have one's a negative slope, one's a positive slope. And we have different y-intercept. One is a negative 2, one is a positive 2. So let's go ahead and graph these. We'll start with the green line. Blow this up a little bit. And we have a negative 2. So our first point will be at negative 2. And then our slope is 2, 3, positive. 2, 3, 1, 2, 1, 2, 3. So there's our second point. And let's go ahead and draw our green line. All right, there we go. Got our green line on there. And let's go ahead and now try to put our yellow line on there. So our yellow line starts at positive 2 and then has a negative 2, 3 slope. So positive 2. So there's our first point. And then our slope is going to be negative 2, 3. So 1, 2, 1, 2, 3. Interesting. It is at the same point right here. And that's not really surprising based on the two formulas, the two equations were very similar. So it doesn't surprise me that that line is right there. And then just go ahead and connect those. All right, good enough, close enough. Now, here's what we want to do. We want to, first of all, focus on the green line. So we want to test a point because we need to know, do we need to shade, do we need to shade this side or do we need to shade this side? And I said it's always easier if you try the 0, 0 for a point, okay? All right, so let's plug in our 0, 0. And we can actually do the same thing on the yellow line at the same time. 2 times 0 plus 3 times 0. Okay. And so this all zeroes out over here. So we get 0 is less than 6. Okay. And so that's true. 0 is less than 6. And so for our yellow line, remember, it's the 0, 0 point that we're using. So that means that this side works. Okay. Let's go over to the green one, and 0 is less than or equal to 6. And that is also true. Oh, I forgot something. I'm glad I remembered it right here. The yellow line is dotted. Okay. Why is the yellow line dotted? Because it's not equal to. Okay. The green line is solid because it is equal to, but the yellow line would be dotted. Now you might want to draw a little bit better line than I drew. I didn't draw a very good line there, so let me go back and try to fix that just a little bit. So, all right, there we go. That looks a little better. And now we test the green line, and the green line also works on that side. So the green line would work on the, remember, this is the 0 side of it. So we're going to fill in the green line on that side. Now, it's a little bit hard to see, but here's what I want you to see. This area right here is filled in both. You see it's got green and yellow. Look up here, just green. Look over here, just yellow. Look on this side, nothing. Okay? On this side right here, it's both green and yellow. Okay, you see that? So basically this line right here to this line right here. And indefinitely going into this, into really infinity. Okay, it goes into infinity there. So everything that's in this little quadrant, if you want to call it that, or in this little section over here, is a solution. Now you might say, but look, this is colored in too. No, 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 that's just in green. It only satisfies one equation. But this down here is yellow. It only satisfies the yellow equation. So the green one only satisfies green. This one only satisfies yellow, so neither one of those. This one doesn't satisfy anything. So the only one that is a solution is over here. Okay? The best way for you to do that on your paper is like if you take like in your pencil and you really make this dark over here. Okay? So you really show me this is the solution, and then you might even take your pencil and circle that side or something so I know, okay, that is, or draw an arrow to it. Yes, solution right here. But mark it so it's nice and clear so that I can see that. And I know that's a little hard, you know, online or virtually, but if you can use different colors or something there to show me what you got, that's what I'm looking for. All right, so there we go. This one, if you'll look down on the bottom of page 254, this one is called unbounded. Unbounded. What does that mean? It means that it extends into infinity. Okay, when I showed you this, it just keeps going, right? So we could keep coloring all the way over here. It extends into infinity. It's unbounded. All right, the next one that we're going to do is bounded. So let's go ahead and go to that one. All right, if you will, in your books, you can go to the next page in your book there. I think it's the next page. No, it's 2 pages, so it's 256, page 256. All right, now this one, notice this yellow line has a parabola, okay, because it's got a square. So we're going to have a parabola going on. How do we solve this? Well, in this one, we're going to have to factor it, and then we're going to have to graph it like we would a parabola. So let's get the, well, the first thing that we need to do, let's do this. Let's before we factor it, before we do some other, let's just let's plug in our h and k. Let's get our vertex. Remember, our vertex is our h and k. All right. So what is our h? Do you remember? You remember how to find that? All right. Our h in this one is 0. because there is no h. Our k is negative 4. Whoops. What just happened there? All right, there we go. Let's try that. So our k is negative 4. Why? Because that. Do you remember you remember this? This was just last chapter or last lesson or a few lessons ago. So what is it? It is our standard form is y equals a and then x minus h squared plus k. All right, so remember, because this is like this, we don't have an h. There's no h there, so it's just the x's squared. But we do have a k. The k is negative 4. All right, so there we go. Hopefully you remember that. That's been a few lessons ago. But remember, in algebra, you can never forget anything. What we learned 3 lessons ago, 10 lessons ago, 5 years ago, you have to remember. So be careful in math that you're not forgetting things. I tell students a lot of times it's like some of you flush the toilet of your brain. You get it in there and then you just flush it down. You can't flush it, all right? You got to leave it there. It's good. You don't want to get rid of it, all right? So leave it up there. Don't get rid of it. Now, that's our vertex. Then, if you remember what we did on the vertex, then we put an x and a y. I'm going to save us some time. I'm going to kind of take the easy road here. I'm not going to go through all that. I'm just going to come down here and I'm going to graph that at 0, negative 4. Okay? So here's our graph. Let's go ahead and put the vertex at 0, negative 4. So 1, 2, 3, 4. All right, right there's where our vertex goes. And if you remember, hopefully you remember, we're going to go 1 over 1 up. One over, 1 up, and then we're going to go 2 over and 4 up. So 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. All right, so they're both back here at this line. All right, so this is going to be our parabola. Not perfect, sorry about that. But there's our parabola. Now, this is interesting. You say, Mr. Steve, how do I know? Remember, these are inequalities. So how do I know? Do I color inside the parabola or do I color outside of the parabola? Well, that's a great question. I'm glad you were thinking right there. So here, that's the question. Which one do I do? Well, what do you think? What do you think? What do we normally do? Yes, that's right. We test a point. So let's test that point. Okay? We are going to test 0, 0. That point is inside the parabola. So let's go ahead and test it. Let's see if 0, 0 works. Let's come back over here and I'll erase some of this stuff so we can test it right here. So 0, 0. 0. All right, so what's 0 squared? 0. So 0 is greater than or equal to 0 minus 4 is negative 4. 0 is greater than negative 4. Yes, that is true. Okay, so we are going to use we're going to color the inside of this one. Okay, because it worked. 0 worked, so we're going to go ahead and color that. Now, so the white line, actually, yeah, I'm going to go ahead and change that because I will put this in yellow so it'll be easier to see. So we're going to color it in yellow. Okay. All right, so there is our parabola. Our parabola is graphed. Now we have to come back over here to our other equation, and it's a line equation. Okay, so this one's going to be hopefully a little bit easier for you to graph. Maybe the parabola was easy for you. You're like, oh, that's easy. I know how to do those. Okay, great. If you don't, work on them. If you do, great. I'm glad. So now here is the line. This one, everybody should know how to graph this one without too much problem. Guess what? I have got great news for you. We are already in y-intercept form. Boom, that was so easy right there. We don't have to do anything. Look, our slope is 1 over 1. There's always a 1 over 1 slope. It's never a 0 slope, okay? So if there's no number there, that's a 1 in front of there or a 1 over 1. And then our y-intercept is negative 2. So let's go back over here. And let's blow this up a little bit, and we're going to put this one in green. So we're going to put it at -2. And it's a little bit hard to see, but 1, 2, -2 right there. So there's our first line. And now we want to do a 1-to-1 slope. So we're going to go 1 over, 1 up. So we're going to go right there. And we can keep doing this. 1 over, 1 up, 1 over, 1 up, 1 over, 1 up. This way, we're doing the same thing. So we're just creating our line, and then we'll go ahead and connect up our line. All right, so there's our line. Now, notice that both of them are solid lines. Why? Because this one is also equal to, and this one is also equal to, so we're going to use solid lines on both of those. So be careful. Your parabola can be dotted too if it's not equal to. So there we go. We got our solid lines, and we're ready to go. We have everything except for we need to know, okay, which side of the green line? Well, remember, this is the one we want to try. We want to try that 0, 0, okay, because 0, 0 is the easiest one to use. So let's go back in here, and we'll go 0 is less than or equal to 0 minus 2. 0 is less than or equal to -2. Is 0 less than -2? No, 0 is greater than -2, so that one does not work. So what does that mean? That means that we're going to fill in on this side of the line. Now I want you to see something right here. This is the only part of the parabola right here that works. Okay? So it's a little bit hard to see, but here's the green line, and here's the parabola. The only part of this that has yellow and green in it, look, let me zoom it in right there. The only part of that has yellow and green in it is inside the parabola and inside the green line. Okay? So there's not much. This is the solution to that system of equations. Just that little area. In other words, the only ones that satisfy both equations are in that little area right there. Okay? All right, that's a lot of fun. I told you this was going to be fun. At the beginning of the lesson, I said this is going to be fun, and it was, right? Did I lie? Okay, maybe a little bit. All right, well, I do hope you had fun. I hope you learned something. Hope you're able to recreate that on tests and quizzes. If you have any questions, rewind that, take another look at it, ask me in the comments section. I'd love to help you out. All right, we'll see you later. Have a good one. Bye-bye.